So when you're dividing polynomials, there is long division, but there actually is a method that's a little bit more efficient called synthetic division. And there's lots of different ways to do synthetic division, but we're going to focus on how do we do synthetic division when we have a denominator here where we're dividing by a binomial. And in this video, we're only going to focus on ones with a coefficient of 1 in front of the x. Now, there are other ways to do synthetic division, but in this case, we're just going to look at binomials with a 1 here. So the way this algorithm works, and the reason why it's more efficient than long division, is because there actually is significantly less writing in this. But what we do is we take the denominator there, and we set that equal to 0. And we write, so x plus 3 equals 0, so therefore x is negative 3. And that's the number that we're going to write at the start. So we're going to take this negative 3, and we write it here. Then we do sort of an upside down division symbol or something like this. And then we list just the coefficients of these terms here. So that just the coefficients of these terms. So we just write the 3, 5, negative 11, and the 3. And we don't include the x squared or x cubes or anything like that. Then our first step is we bring down this 3 and we write it here. And now we multiply the 3 and the negative 3. So we multiply these two values together, and we write the answer under the 5. So here we have a negative 9. And now we add these two together. So we do 5 plus negative 9, which gives me negative 4. Then we repeat again, but we take the negative 4 and we multiply by the negative 3. And so that gives me positive 12. And then I add the negative 11 to the 12, which gives me 1. And then I take the negative 3 and I multiply by the 1. So it gives me negative 3. And then I add these two together and I end up with 0. So this number here, this 0, on the further right number, this is our remainder. So in this case, we have no remainder. And this one here, the 1, this is our constant term. This will be our x term, the coefficient of our x term, and this will be our x squared. So you always want to read it from right to left. So the right one being the remainder, then the constant, and then x squared, and it goes on from there. So the answer to this question, the 3x cubed plus 5x squared minus 11x plus 3, all divided by x plus 3, the answer to that is 3x squared minus 4 plus 1. Sorry, minus 4x plus 1. So that's the answer to that question. Pause the video and see if you can do the one on the right. So this one here has a remainder of 0, and that's a term. And as you can see, if you've already done long division, you can see this is a much more compact and efficient way of doing this. So let's go on to the next one. So we're going to, again, set the denominator equal to 0. So we get x is 1. And so the 1 is what's going to go on the left side of this synthetic division. So we're going to write 1. Then we write our coefficients. And similar to long division, is for this algorithm to work, you have to use all of the values. So I have an x cubed here, but you notice there's no x squared term in this function here. But I do need that as a placeholder for the division. So I'll write my first coefficient of the x cubed, and now the x squared coefficient is going to be 0, x is 2, and the constant is negative 5. And now I repeat the algorithm. So we bring down the 3, we do 3 times 1, which is 3, and then we do 0 plus 3, which is also 3. We do 3 times 1, which is 3, 2 plus 3 is 5, and then 5 times 1, which is 5, and again we get 0. So again, reading from left to right, I see I have a remainder of 0, a constant term of 5, the x coefficient is 3, and the x squared coefficient is also 3. So my answer to this would be x squared plus 3x squared plus 3x plus 5. And that's the answer to that one. So again, pause the video and try the one on the right. So in this one here, we see the remainder in this case is not 0. And so the way we write that is we take this remainder and we divide by the original binomial that we're dividing by, and that's the final term. So in this case, we do have 4 terms. We have x squared minus x minus 3 minus the remainder, which is 18 over x minus 3. Okay, let's try another one here. So we have x minus 1 equals 0, so x is 1. So we write that here. And we write all the coefficients, 1, 5, negative 1. Bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. And then negative 1 plus 6 is 5. So in this case, we have our remainder. We have our constant term. And we have our x term. So the final answer would be 1x plus 6 plus 5 over x minus 1. And again, like the previous example there, you take the remainder here, you divide by the original binomial you're dividing by, and that gives you the remainder that is part of the solution. And so that would be the answer there. So pause the video and try the one on the right. So the answer to that one is 2x minus 7 plus 16 over x plus 2. So this is how we do synthetic division. As you can see, it is a bit more compact. The drawback of this is it doesn't work for dividing all types of polynomial division, especially if you have a trinomial or an x squared in the denominator. This doesn't work. So really, the way I've shown you now only works if you have a binomial with just an x term and the x has a coefficient of 1.